Alright kids, it's time to start 10.2, working with the base of an exponential expression. So first we'll start with some notes. Big one, notes. Little a. Let's recall the what an exponential expression looks like. So recall a times b to the t is an exponential expression. Okay, and remind me what a represents. Right, that's the initial value. And remind me what b represents. That is the growth factor. And remember that factor means this is what I multiply by. So this is the number we multiply by all the time. So then, let's see. So, excuse me. So then, now that we have that, let's talk about little b, growth factor versus growth rate. All right, well, we know the growth factor is b. All right, but the growth rate is the percent rate of change. And we're going to denote that with a lowercase r. All right, so what's the relationship? We're going to have the growth factor is equal to 1 plus r. So therefore, if I solve this for r, I get r equals b minus 1. So these are two little equations we're going to use a lot here to go back and forth between the two. All right, so if I move up a little bit. So if r equals a 10% increase, then r equals 0.10. So b would be 1 plus this, which is 1.10. If r equals a 10% decrease, then r equals minus 0.1, which would mean b would be 0.90. Remember, the growth factor always tells us how much we keep. So if I lose 10%, that means I keep 90% of it. All right, let's go to the next page. Make sure we can see everything. All right, try that. Turn the light on. All right, little d. Let's see, if q equals 200 times 1.041 to the t, then what's going to be all the values here? Well, we have the initial value is 200. The growth factor is 1.041. So then what's the growth rate? Well, the growth rate is going to equal the growth factor, 1.041, minus 1, which is, in this case, 0.041. So then we write that as a percentage, so that means that is 4.1% increase. All right, try another one. If we have q equals 50 times 0.992 raised to the t, then what are all the values? We have the initial value is 50. The growth factor is 0.992. And the growth rate is 0.992 minus 1, which gives us negative 0.008. So this in turn means that we have a, let's see, 0.8% decrease. Okay, so remember we can use the word increase to mean positive and decrease to be negative. All right, so don't worry about that too much. Okay, now the next big thing we're going to look at today are tables. So little e, if I'm given a table of values, how can I tell if it's exponential or not? So working with tables. So let's see, so little 1, we'll look at number 49 out of the textbook. So we're given some x values and some y values. See, the x values are 0, 1, 2, and 3. Y values 1, 7, 49, and 343. First thing you want to look are at the delta x's. Here we have a consistent delta x. So delta x equals 1 everywhere. All right, because if delta x isn't the same, we have to think a little more. So now what we want to do is we want to look at the quotient of consecutive y's. So we look at 7 divided by 1, 49 divided by 7, 343 divided by 49. So if we have 7 divided by 1, that equals 7. Now look at the next one. 49 divided by 7 is 7. And 343 divided by 7 is again 7. So all these are the same. So that means we have a constant factor here. If you remember when we were doing linear things, we wanted the difference to be the same. Well, here we want the quotient to be the same when the change in x is the same. All right, so in this case, our factor's constant, and we know our initial value, right? That point there gives us our initial value. So we can come up with our equation. So if we have y equals a times b to the x, we know from here a equals 1, and we know from here b is 7. So that means y equals 1 times 7 to the x, or if you prefer, y equals 7 just to the x. Okay, now how about a little bit, went a little low there, there you go. All right, now how about something a little harder? What if we look at number 51 out of the textbook? Here we will have x against y again. The x values are 4, 9, 14, and 24. Y values 5, 4.5, 4.05, and 3.2805. All right, well, some things to keep in mind. We do worry about the change in x's here. So here we have delta x is 5. Then over this interval, delta x equals 5. Then over this interval, delta x equals 10. But notice that the delta x being 10 is just 2 jumps from what we had. So basically, we're skipping a value in here. We're skipping 19. We could have gone from 14 to 19, 19 to 24. So just keep in mind, this is like 2 times 5. All right, so this is how you're going to want to think about these every once in a while. All right, so now we divide. 4.5 divided by 5 is, you can use your calculator, that's going to give you 0.9. Then this one, 4.05 divided by 4.5 is 0.9. But then when we do this one, 3.2805 divided by 4.05, we should not expect to get 0.9 because this made 2 jumps. When we do this division, we get 0.81. Now, since I had 2 jumps, you have to think of what the constant value was previously. It was 0.9 and 0.9. So what would happen if I went from 4 to 14? I would have 4.05 divided by 5. That gives you 0.81. So what we have to deal with here is this 0.81 is like 0.9 squared because I had 2 jumps. Okay, so since I doubled my change in x, I have to square or figure out what this number is the square of. Okay, So now, since we figured all these things out, we know that our b value, our growth factor, is 0.9. But we don't know a. So what we can do is we can write this in a very slick way. We don't know the y value when x is 0. So what we can do is pretend this is our first point. So what we'll have is y equals, just use that 4. Was it supposed to be 4? No. 5, right? Because that's the y value. So we want that 5, I wrote that badly. 5 times 0.9, and then what we're going to do is, how far from 0 is this? This is 4 units from 0, so do x minus 4, right? Horizontal translation to the left. And then you divide it by whatever the delta x is. So divided by 5. And that's your exponent. So what we do is, now we simplify this. So if you remember from a couple sections ago, this is, or from last section actually, this is 5 times 0.9 to the 1/5 times x minus 4. So that's going to be 5, 0.9 to the 1/5, x minus 4, 5, 0.9 to the 1/5 to the x times 0.9 to the 1/5 raised to the minus 4. So now what we do is we plug this value in the calculator, multiply the 5 times this whole thing right here, and this gives us y equals, where's my answer? I had it ahead of time. 5.440 times 0.979 raised to the x. And this is the answer right here. That's our equation. Sorry, I let it a little low. Okay, so we're running out of time, so go ahead and start your homework. This should be able to get you everywhere you need to be, and I'll see you in class on, well, tomorrow.